Welcome to the practical guide to the Git command line. It attempts to be teaching you everything you need to know about how to use the Git command line in just a few minutes using a practical example. Well, to have a practical example, first we have to understand what Git is used for. Git is a distributed revision control system, which basically allows you to track changes to a directory on your disk. These changes can then be, well, distributed to other parties who can use it as their own. And you can resync the changes that other parties do to your directory tree using Git and Git only. And that's quite practical if you want to work in a team and if you want to work in a situation where internet is not always available or required. So first of all, let's say we have two users. We have Carl and we have Lenny. That's the guys. I recently learned that Carl has an IQ of 212, so he's apparently real smart. And yes, Carl and Lenny, they're in a deep bromance, you could say. They probably live together in a flat share and they're best friends forever, that's for sure. So considering they live in the same apartment, they use the same computer, so we have users Carl and users Lenny. They can access each other's data with ease. So Carl, he's the smart one. He wants to learn how to program Python, I say. So he sets up a new project, which is hello world, like that. Maybe like that, because it looks better. And all he has to do is to make a file that prints hello world. So let's do this quickly. Let's call it helloworld.py. And let's call Python user bin Python. That's all unrelated to Git really, but we have to have a program that does something, I suppose, so we can change it and improve on it. All right, so if we make this executable, we should be able to see hello world here. Awesome. So that's the first state, and he would like to show it to Lenny, but maybe Lenny wants to edit that as well. So I believe Carl realizes that using Git is a good idea here. So first of all, we want to track the changes in the hello world directory. So we say git init. Git init initializes a Git repository, which is initially empty. You can get the status on your repository with git status. And we see we are in our initial commit. There is one untracked file, hw.py, and we are on our branch master. More on branches a bit later. Let's just say master is kind of the default evolutionary lane that you will use in most Git repositories. That's the default. And as you can see, my shell is smart enough to realize, oh, I'm in the Git repository and my checked out, or let's say my branch that I'm currently on is master. In order to add these files, you can use git add. And you either say you want to add specific files, or you say I want to add the entire directory. The dot on POSIX systems and even on Windows signals that you wish to deal with the current directory, which is what I want. If you hit git status again, you will see that now we have changes to be committed. The new file is hw.py, but we didn't yet commit anything. That's important to realize. If you have no experience with other revision control systems, this is nothing special to you. If you have experience with SVN, let me tell you that Git has a staging area. You know, it calls out for this one here. The staging area is allowing you to prepare your next commit. And right now we only have one file here, and maybe we want to have another file, readme.txt, my first Python program. How do you like it? Another git status will reveal that now we have another untracked file, readme.txt, which is the file I just created. And if I want to make it part of the next commit, I'll just add it. This time I just specify the file directly, even though I could also use the dot notation again. As we can see, now we have 2 files to be committed, and what we can do is to just go ahead and commit or create a new commit with Git Commit. If you don't hit any command line arguments there, it will bring you a default editor. I think it's a Vim on most systems, which allows you to set up your commit message here. My first hello world. Awesome. It's a pro tip, I'd say, to use the first line as a single 80 characters, 1-line summary of some more information that you might provide in the next lines like this. So I have a free line here, and here you can type away and say everything you ever want to say about your commit. Then once you write the changes and leave the editor, your commit has been created. You can see the history on your current branch by asking for it using git log. Git log currently just shows 1 commit, and it actually tells me that I'm me, and that's something that you should probably fix, because that's the first thing you have to do when you set up Git. Basically, you will have to configure your username and your user's email. Username, git config, username is Carl, and user email is carl@simpsons.com, I suppose. Nice. So if you make another change here, you will see that the next commit we create will actually use Carl as a user, because this repository now thinks it belongs to Carl, which is actually the case. So something we can do to speed up the committing, I mean, I just aborted the add operation here, so you see we still have a modified file. Something we can do to speed up the commit is to say commit all modified -a, and M stands for message. So I'm committing all modified, and I'm entering a message right on the command line, which says, well, usually you would say something useful here. Added more awesomeness to readme file. Definitely so. If you have a look at git log again, you see that the commit now has been created by Carl, who can be reached at carl@simpsons.com. Awesome. And that's what you would want. In the moment you do a first commit and you didn't set up your user yet, Git will tell you. So you should definitely do that. Great. So we could continue here forever and keep tracking our changes, and it's kind of staying the same deal. But let's just say that Carl would like Lenny to have a look at his program, but Carl doesn't want Lenny to mess around in his own folder, so Lenny should better have its own, right? Which makes sense. If you have your own copy, you isolate your changes from the ones other people might do. In order to achieve that, Lenny will clone Carl's repository. So let's go to Lenny's folder first, just to make it a bit more obvious that we are interacting, or that we are Lenny right now. And we want to clone Carl's Hello World initiative into our own. And we are done. So as you can see, all we had to do is to specify a folder here that we want to clone. This, in fact, can be any URL. You can clone from the web, you can clone from secure shell sources, SSH, pretty much from anything. Cloning from a different folder on a disk is, well, the simplest thing you can do. Probably something I messed up here is that I used a relative path, but we will see about that. Let's have a look at the Hello World clone that we just created. And first of all, let's be sure we are who we are. User name is Lenny, and user email is lenny@simpsons.com. Great. So Lenny will now have a look at the program and make it much better. Maybe by adding some exclamation marks. And he will also have a look at the README file and answer this question. Lenny says, could need some spice, maybe. It's rather boring, you know? Just hello world. Added some spice, if you don't mind. Maybe he does, but we will find out. Right now, this change only exists in Lenny's clone. And we would like Carl to see the changes, right? So first we have to make a commit. As usual, because these files are already tracked, you know, Git says, oh, changes that are not staged for a commit. So we stage them using -a for add all modified files to the index. And as a next step, just make a commit with the following message. Added some spice. Ooh, that's very mysterious. We can also just have some more detail on the command line here and be much more informative. You will see what I meant. Mwah. Har, har. Let's see what he meant. Let's finish up the message here. And I messed up my command because I don't want to git add, I want to git commit, of course. Like that. Let's have a look at the log. And now we see that some change has been performed by Lenny, which is right on top or after the last change that Carl has been doing. Good. So Carl, you know, he has had a good time and didn't really continue working on his program. By the way, let's have a look. Oh yeah, that's very spicy. So Lenny lets Carl know that there has been a change and that he should have a look at it. So we go back right to Carl and try to get the changes from Lenny. But I tell you what, just because Lenny cloned Carl's repository doesn't know about that at all, doesn't care. So what Carl has to do now is to let his repository know that there are other repositories that he wants to sync with. These remote repositories are called remotes. It's that easy. So we have to add a remote that points to Lenny's repository. Let's do this. Git remote, add. Now we have a name, a symbolic name for the remote that we will use in future to synchronize changes. The default name is origin in the in the Git world, but as we know that our remote is going to be Lenny's remote, we will just call it Lenny. And now we have to provide the path to the remote repository. We'll just use relative path here again. And my shell completion doesn't work, but I know that it is that one, hello world. So let's see if that works. If I just call git remote without any arguments, it will show me the remotes I have. Just by the symbolic name, which sometimes is what you want, sometimes it might not be enough. If you do a -v here, we see that the path to our remote is a relative one. That's always dangerous, by the way, pointing at Lenny's remote repository. Awesome. So all we have to do now is a fetch. A fetch gets all the changes that possibly have been done in the remote repository and puts it into our own repository, but it keeps track of where the changes are coming from. For instance, git fetch Lenny will get the changes and point to them in a new branch. Look at that. So what this means here is that it used the master branch in the Lenny remote repository and placed its contents into our remote tracking branch, which is called Lenny master. And if we run our own hello world file, we still see that, obviously. It's still that, it's still the old version. Nothing has changed for us because the changes are actually in Lenny master. So have a look at the git log. If you don't specify anything, it shows you the currently checked out branch. And Lenny's commit is totally missing. But it's not really missing, we're just not seeing it yet. So one way to have a look at the other branch's content is by just specifying it, Lenny master. Now you see that this branch obviously has Lenny's commit, which is exactly what we wanted. But we also want to have a look at it. So there are multiple ways to do this. First, I can check out Lenny master, but the way to do this is not to check out this branch directly. Well, but we can try. Let's just try it. Check out Lenny master. And what it did, well, now it gets a bit more difficult. What it did is it detached my head. This is just for looking around. You will see that you are on a detached head by the name here that changes from a nice readable name, master, to some shortened hash. This really means that you can't work here, but you can look around in the working tree. So for instance, if we should execute our hello world program, we see that now it's the one that Lenny used. And if we log, we see that we are on the last state that Lenny provided. At least it's seen from our point of view, because the last state is always what you fetch, right? In the meanwhile, if Lenny would work and make some changes, we wouldn't see that until our next fetch. So synchronization always happens with git fetch. All right. So I want to go back to my own state just to prove it. Hello world changed back to what it was before. And I actually do like Lenny's change, right? I've had a look at it and I love it. So what I want to do is to merge his changes into mine. Wow, a merge. This happens automatically, and usually if there were no conflicting changes, there's nothing else that you will have to do. In this case, there is no conflict. I can tell you that because Lenny has made a change, and in the meanwhile, we didn't do any change. So there's no potential for conflict here. Only if two changes happen kind of at the same time, there is conflict potential. In this case, there's none. So let's do a merge of Lenny's master branch. Nothing else to say here, just do it. And as you can see, it updates our branch from this commit to that commit. It tells us that it's a fast forward. Why it's a fast forward? Remember the history that we had. The history was kind of just linear. There was no real branching and forking going on. It was just a single line of commits. And if there's a single line of commits, that is, if your branch can move to the branch you want to merge to just directly, because the branch you want to merge to is in the future of your own branch, then you will always get a fast forward. Which means that if we now show at the log of our branch now points to the same location as Lenny's branch. In my shell, I have a little alias that shows me the history in a more graphical way. And as you can see now, my head is pointing to the same commit as the master branch, as Lenny master. So they all are at the same state now. This is what I've just achieved with the merge. That is just about it. So let's make another change here and let's remove some spice, because, you know, might have been a bit too much. Just one exclamation mark, that should do. And let's have a look at the README file. If you don't mind, well, I did mind. Carl says, well, too spicy for me. Obviously, this little dialogue we could also have in the commit messages, but hey, let's just have it in the README for now. It's more like a changelog then, huh? Let's change the file name to changes.txt. The thing is that in the moment a file is tracked by Git, you have to use Git's own command in order to rename it. For instance, if I would just rename the README file to changes.txt, and if you do a status on it again, what would happen is that Git would detect that the README file has been deleted, and now there's a new file that is untracked, which is changes. And it's not a problem in a way. We can just add this new file and Git will actually figure out that this is just a rename. But we can also do it right from the very beginning and use Git's own move command to do that. So first I roll back what I've just done. And then I use git move to rename my file. The status now reveals that, oh, Git knows that I'm renaming this file. Awesome. And despite the rename, which is already staged here, I still have changes that are not yet staged for the next commit. So I could use git add. Let's do this time. As you can see, now it tells me the same thing. I have actually the file renamed and there are changes to it. But as far as Git is concerned, it doesn't matter. You know, that's the change it tracks. And we have the modified file here. If I wanted to see, by the way, what I changed or what I'm going to commit, I can diff the changes. Oops. I think it's cached. That's the one. Ha. So with that, with git diff, you can compare different states of your repository. Right now I told Git to tell me what changed between the index or the stage of the stuff that I'm going to commit compared to the last commit. As you can see, the hello world program changed. So instead of 3 exclamation marks, it's just 1. And what it tells me is that one file has been deleted and another file has been added. That's not entirely true, actually, because the diff here, it didn't track the rename. You know, it tells me, oh, readme was deleted and there's a new file that is changes, but that's not the case. I think with -m, you can track renames. So as you can see now, the diff tells you, all right, there are 2 files that have been renamed, or there's 1 file that has been renamed. The new file is quite similar, 81% similar to be precise, and apparently the only change that has been happening in the rename file is this edit new line. That's more like it. So if I commit this now, I can say, well, removed some spice and that shall be it. Awesome. So something else that we could do is now go back to Lenny and make another change, you know? In the meanwhile, obviously, Carl has made some gorgeous changes there, but Lenny, you know, he just keeps going. He's on the roll here and wants to make it even better. So let's make it even better and maybe add one more line to the Hello World program, which does something special. Print Hello World. And now we just take ownership by Lenny. That's a bit odd, huh? I mean, I could imagine that Carl doesn't really like to see that, because after all, Carl was the original author of that gorgeous program. Let's just see how this looks like, and let's commit the changes right away. Added my name to make myself, of course, unstoppable. Well, that was not the term I wanted to use, but you know what I want to say. Probably not. Anyway, here we go. We have made another change to the Hello World program, and now Carl tells Lenny, hey, you know what? I removed some spice from your version. Please have a look. Please check the changes here. So what we can do in order to fetch the changes from Carl and merge them in right away is to git pull. So git pull is the same as a git fetch and git merge. And the git merge always needs to know which branch to merge, and therefore git pull might just not work right now because we didn't set up any relation between this master branch and the remote master branch that you would like to pull. But we will see if that works or not. Git pull. Now we have a conflict here. So let's see let's just read through there just to see what happened here. Auto merging hw.py. Oh, there is a conflict now. It's auto merging changes, that's fine. And then it tells you automatic merge failed, fix conflicts, then commit the results. So that can happen, that can always happen. If two people are working on the same file, for instance, as we just did. And the first thing you would want to do is to have a git status on the changes here. As you can see, we have unmerged path. While there's an unmerged path in your index, or on your stage, basically. Index equals stage, you know, you will see this a lot. Cache is another term for the same thing. Index, stage, cache. Git isn't exactly consistent there. But as long as you know, you will deal with it, you will be fine. Both modified, hw.py. Okay, so let's diff it. If I say this, what it will diff is the working tree compared to the state in the index, A git diff compares my working tree, which is basically the contents of my folder, with the contents of my stage, of my index. And look at that, what we have here now. Ooh, that's a tough one. But it's actually not that tough, You have to get used to these weird signs and stuff, and just learn to read it. So let's get into an editor and modify or resolve the changes here. All right, so what happened is that the head state here is my state. That's where my own head, that's where my own checked out state pointed to. That's my version, obviously. Hello world, 3 exclamation marks, and then we have by Lenny added here. And the other version is the one that Carl de-spiced, so less exclamation marks. And I just have to choose now which version I want, and I have to build it myself. And these markers here, they're just merge markers. They have to go away. That's something that should never remain in a file that has merge conflicts. So let's remove this, and let's remove that. And now we end up with one line too many, and what I'm just doing now is I'm taking this line by reproducing it, and then I can remove the change that was done. So now I've just resolved the changes, but if we check Git status, you still see that for Git nothing changed. This is because we have to add the file here that contains our resolution in order to mark it resolved. Let's do this. Okay, now the Git status says, all right, we just have a modified hw.py, and it told us once we have resolved the issue, we just should git commit to conclude the merge. We are still in a pull here, remember? We still have to do the merge conflict resolution that just occurred to us. As we said, git pull is like a git fetch plus a git merge afterwards. Let's commit to conclude the merge. This is the commit it generated for us. Merge branch master of the absolute path to user Byron, user Lenny, and then Carl hello world. That looks like a weird path because it's kind of, going up and down, but that's basically just saying, hey, we fetched Carl's master branch there and we resolved this conflict. That's fine. I don't have anything to add here. And now what would be interesting is to see a graphical representation of our commit history. If I do a git log, you just have a flat history that always looks linear, even though it is possibly not. So let's use our special command here that shows how the things can diverge. All right, so this is our first 3 commits. Nothing happened here. Linear history, and then Lenny and Carl started to edit the same file at the same time. So this is, I think this is Lenny. Lenny edited his name, and Carl in the meanwhile removed some spice from the Hello World program, and this resulted in a merge conflict that we have just resolved. As you can see, here is where the states of the repository have diverged, right? And here we bring the states together again, putting them on the same level. Interestingly, this change just exists in Carl's repository, in Lenny's repository. We're still at Lenny's place here. If we go back to Carl, look how that looks like. Well, there's no branching going on. It's just his removed spice. Nothing else. So in order to see the changes that happened, we have to, fetch. Let's try pull here, maybe that works. Pull from Lenny. Nice. You asked to pull from remote Lenny, but did not specify a branch. Because this is not the default configured remote for your current branch, you must specify a branch on the command line. So what it tells me is, it just fetched Lenny's latest changes, but it wasn't able to merge the changes in because it has no idea which branch I want to merge in. I didn't set this up. Let's have a look at branches, because now they're so prominent here, we really have to understand what that means. So actually it's this command, Git Branch, shows you the current branch you're on, which always is highlighted in green, and I think it's also this asterisk that kind of marks it. If you want to receive help, by the way, for any Git command, just say git help and then the Git command, and then we'll show you everything there is. Quick help is just -h, right? That's pretty much it. And right now I would like to see remote branches. Okay, that's the Lenny master. And also I want to visualize what's going on. So the default position of or starting point of the visualization is always the position of your current head. The current head points to the state that you have checked out in your working tree. This is the thing you see on your hard disk right now. As you can see, there is no branching going on, but if we look at Lenny's master, we see that we have fetched Lenny's state. It's just, you know, not merged into our state yet. We are still seeing this part. And if you just look at it that way, if you just go back the line here, you understand why the default visualization that starts from head just has linear history, right? It just doesn't see the future that basically starts here. You know, it doesn't see that. It just goes backwards. So what we want to do now is to make our master branch move up to Lenny's master branch. And this is something we can do easily by merging manually again, or we can set up, we can define the upstream branch that we want to track and merge to automatically when we do a git pull. This will just speed up our workflow here. And that's the set upstream to command of Git Branch. So let's do this first. Git Branch, come on, let's try to type this correctly. Set upstream to, and which branch do we want to use? We want to use Lenny master. That's the remote tracking branch here that we want to associate our local master to. Branch master set up to track remote branch master from Lenny. That's pretty much what we just did. So if I say git pull now, it will fetch again, no new changes, but it will also merge Lenny master automatically. Voila. Let's have a look at the visual history. And as you can see, we are now in the same state as Lenny master, and we see all the history that has happened so far. If we execute our program, we see, oh my god, hello world by Lenny. I do not concur. I think I have to fix this right away. I mean, we are Carl here, and we were the ones who did that. And now we could start an edit war. Fixed copyright, kind of. It's mine. Make your own, Lenny. And then PS. Still love you. In a bromance way, of course. Like so. Alright. So now, if we go back to Lenny and we pull, you will get the latest changes automatically because here the tracking has already been set up. And now it's Hello World by Carl. And this is how we should conclude our session. Let's recall what we learned. Git init initializes a new repository. Git clone allows you to clone from any URL, but any clone is independent of the remote repository that it has been cloned from. Git remote shows us the remote repositories that we have, and if you use -v, you see the actual URL of the repository. In our case, it's just a path, but it could be a place on GitHub or anything else. And git add allows us to add the changes in our working tree to the index or to the stage. It's the same. Git commit allows us to create a new commit that will then be visible in our commit history that you can ask for using git log. And last but not least, once you have remote repositories, you can fetch from them, which will just pull the changes but not adjust your working tree at all. You can pull, which is a fetch followed by a merge with the respective remote branch that has been associated with your local branch that you are on. By the way, before we conclude this, let's have a look at the remotes again. Because here we see that once we cloned Carl's repository as Lenny, obviously, it created a default remote that is called origin, right? That's totally fine, it's still pointing to Carl, but maybe it's not so obvious. So let's rename the remote origin and call it Carl. So if we have a look at this now, we see what just happened. And if I have a look at the branches again, you know, -A shows me all the branches. It now tells me that, okay, I have my local master branch, and there are these remote branches that are Carl master. That's the remote repository state that I've last fetched. Good. That's pretty much it, except for the last command, git diff. Git diff by default shows the differences between your working tree and the index, the stage. And diff cached shows the differences between your stage changes and the last commit, which can be useful if you have already some stage changes and you want to know what you commit next. Then you would do this. All right, that's it from now. Then one of the next videos will probably be about some in-depth knowledge on how to use Git. Thanks for watching and hope to see you around.